Okay, so it's a difficult integrand, and they're giving me a reduction formula to use right over here, all right? Now, I don't see that reduction formula yet, but probably is going to pop up through the work. Let's take a look at it. First thing I did was make a substitution, and it's going to be a trig substitution. So I'm saying that theta is this interval here, and the reason for that is that I realize I'm dealing with the root of x as my substitution over here. Let me just back up a little tiny bit here. So this is going to be my substitution over here. And again, the tan of theta, well, if I look at that over there, on this interval over here, it's going to be from 0 off to infinity, which is what I want, by the way. And then, what are you going to do over here? I square both sides, relatively simple to do. I notice that x plus 1, also relatively simple to do, just adding 1 to both sides of that. And then I notice that 1 plus tangent square of theta is this thing over here. These are things that I need, by the way. I need these things. All right? So what do I know now? X is equal to tan theta, and now I know that the root of x plus 1 is a secant of theta. I'm going to put the differential down now, dx. How do I do that? I'm differentiating this over here. So 2 tan theta, secant squared theta d theta. I go back to my original integral, this one over here, and I make my substitution in there. So what do you get? Well, natural log, well, the root of x plus 1 is just secant theta, and then the root of x is tan theta. And the differential dx is this thing over here. Now, of course, comes the tough part, an integration by parts. All right? So what are we doing over here? Let's get my eraser out. Erase this business over here. And we're going to make a substitution over here. So I'm going to let this to be the u. And I'm going to let this thing over here be the dv. Let me put my green ink down. All right, let's go through it. And one step at a time. So this is the u. This would be the du. All right, so it is going to be 1 over the argument. Then I take the derivative of the argument. Fairly straightforward. All right. The next thing, I realized I could simplify that by just simply factoring the top. Let me write that down for you. Secant theta plus tangent theta. And I'm going to factor out a secant on top. And what do you get there? Tangent theta plus secant theta d theta. What cancels off? These things cancel off. You're left off at secant theta. Fairly simple. And then dv, and so where's this coming from? Well, we kind of just did it. I mean, hopefully you see that there, and you know what it is, right? So let's put that in there, and we'll go for it. So what do you put down? You're going to put down the uv. Let's see, the u and the v minus the v du, tangent squared, this thing over here. All right? So we have a remaining integral we have to concentrate on now, and that integral we're concentrating on is this one over here. Right, I'm going to concentrate on that now. Let's write that down and do it. So we're doing this guy right over here now. All right, first thing I did was basically rewrote the tangent squared as secant squared. And this is where the reduction formula is going to come in. All right. So I would recommend using the reduction formula provided to you. And where is that? Right over here. Again, I would recommend using that. And that's exactly what I did, by the way. And so when I did that, use a reduction formula, not to go through the gory details of it. You use reduction formula in this one over here. And this one you should know at this point. We get this over here. Then I combine them together. And you got a half minus 1, which will give you minus 1/2. I'm seeing this over here. Fairly simple. All right, let's keep moving forward. And we're going to try to pull it together now. And what we're pulling together is the whole integral now. We're pulling this thing together. We got this. And we got this now. All right, all the symbols of integration have been moved to the right-hand side. And then what I did, I plugged things back in. And since I don't remember what those things are going back to the land of x's, way back up here. So remember, I need this and I need this. And that's all I did over here. Now granted, when I say that's all I did over there, you get this over here. Does that require work and effort? This requires work. What's the work? Here, you need to plug in, like for example, tan of theta, root of x, and you need to plug in the secant of theta equals the root of, just to remind you where this is coming from, right over here, it's the root of x plus 1. Whoops. That's all we're doing. We're taking this and plugging the stuff in. And then, of course, some algebra, you surely get this over here. Thank you.